Hello, fellow problem solvers. So today we're going to be doing a problem, which is probably the first polynomial problem I did as a competitor. It's probably one of the first actually more serious, more non-trivial, I should say, like more non-theory based polynomial problems I did as a competitor. And I really, really like it. So I'm going to invite you to try it out for a minimum of 20 minutes, ideally 40 to an hour, not more than 2 hours. If you'd like to go along with us, give it a go for the next 10 to 15 minutes and put your first ideas out on paper. So your polynomial of degree 4, it has integer coefficients and is divisible by 7 for every integer x. Ooh, show that 7 divides every single one of these coefficients. So this is divisible by 7 for every x. Show 7 divides this. Well, what can we do? Well, let's see. So for x equals 0, this is divisible by 7. But what is this equal for x equals 0? Well, this is equal to if x is equal to 0, then this is equal to e. So now we know that 7 divides e. Yay. Now if we plug in a 1 for x equals 1, we'll have 7 divides a plus b plus c plus d, right? Because this becomes 1 plus 1 plus 1 plus 1, like 1a plus 1b plus 1c plus 1d plus e. But because 7 divides e, we can get rid of it and we just have 7 divides a plus b plus c plus d plus e. We gotta use the condition somehow. What happens when we put in a minus 1? Well, we get a 1a, we get 7 divides a, then minus b, and then plus c, and then minus d. So now from these two, what do we have? I here invite you to pause for 5-10 minutes, push the problem further. So what do we have here? Well, when you add or subtract, when you add, you'll get one thing. When you subtract, you'll get another thing. But when you add, you get 7 divides 2a plus 2c. But 7 has nothing in common with 2, so 7 divides a plus c in this one. And 7 divides b plus d. We can combine these things to get these things, but the most building blocks are 7 divides e, divides a plus c, and it divides b plus d. What do we do now? Well, we've been plugging stuff in to get more and more information, so let's plug in a 2. What do we get now? What is 2 times 2 times 2 times 2? 16. 16a plus 8b plus 4c plus 2d plus e, but we don't care about the e. Now, what can we do here? Well, we can, subtract the numbers that we need, but we can also plug in a minus 2 right from the get-go. We get 16a minus 8b plus 4c minus 2d. And e also plus e, but 7 divides e, we have that already. So now, when we add them together, we get 7 divides 32a plus 8c. Now, because 7 and 8 have, this is equal to 8 times 4a plus c. Now, 7 and 8, what do they have in common? 1, their GCD is 1. 7 divides 8 times b. 7 is relatively prime to a. 7 divides x times y. 7 is relatively prime to x, so 7 divides y. That is the rule that we are using here. And from here, it follows that 7 divides 4a plus c. Now I invite you to finish up the problem. Take 5 minutes, 5-10 minutes, finish it up. And here's the next step. Well, 7 divides 4a plus c, and it divides a plus c. So it divides their difference, which is what? 7 then divides 3a. 4a minus a is 3a, c minus c is 0c. So 7 divides 3a. What do 7 and 3 have in common? Nothing. That is correct. So that implies what? 7 divides a. And now we have 7 divides a. And now from here, it follows that 7 divides c. So now we have 7 divides a, c, e. What do we do with b and d? Well, we've sort of finished by doing what? I invite you to pause for 10 minutes, push the problem further. We did what? we added, well, let's subtract. Let's see what happens when you subtract. So you get 16b, like 7 divides 16b plus 4d. This is 4 times 4b plus d. 7 and 4, what do they have in common? I don't know, I don't think they have much in common. Exactly, they have 1 in common as a divisor. They're relatively prime, so 7 here then divides 4b plus d. Now, it divides this. It also divides this, so it divides what? Their difference, which is 7 divides 3b. And from here, well, what do we have? 7 divides 3 times b. 7 and 3 have nothing in common, so 7 must divide b. And this implies that 7 divides b. Because 7 divides b, and it divides b plus d, it follows that 7 divides d. And that is how we've proved that 7 divides a, b, c, d, e, but not g. Why not? There's no g. Actually, I forgot an f. So I need to work on my alphabet next time. But we finished up this nice problem. I kind of like it. And as always, thanks for problem solving.